Okay. Hello, everyone. Uh, Today is very beautiful autumn day. It's already autumn in Russia, and today we are going to start our new live demo webinar, which is completely dedicated to cable fault locators by Techno AC. And before starting the event, I would like to know if you can hear me or see me well. So send plus in chat box. I will check with my phone. Just hold on a second. I will open the chat. Yeah, I see. So if you can hear me or see me well, let me know. And we will start shortly. For those of you who don't know who I am, my name is Dmitry. You can call me Dima. And I'm responsible for technical consulting at Techno AC. And I also do uh, technical training and demos at Techno AC. And mostly me and my colleagues are answering your questions in emails and in WhatsApp and everywhere when they are considered with some technical specific conditions. And today we're starting a unique event, which is dedicated to the new product line which we're launching. We didn't have an official launch due to a coronavirus, but we're launching it today with you. This product line is completely composed of time domain reflectometers. We will be seeing them working live today. And also, we will be checking the electromagnetic cable fault locators by Techno AC. Here you can see a DODK sensor. Some of you may see it on our website. And also, we're having a DKI sensor, which is here, ready for an operation. I will also demonstrate it to you today. And of course, we can't use these devices without our locators and transmitters. AP, this is AP 19.1, and this is an AG105. You are quite familiar with this transmitter, and I guess you already know how does it work. That is why we will not be paying too much attention to it today. And also we have TDR 4.7. This is the most advanced time domain reflectometer that we're having for today. And this one is TDR TA3.3T. We just call it TDR 3.3. That's just easier to remember. This is a portable device, and it has some differences, of course, from the bigger one. And I will try to explain what's the difference. And today we will see how does this equipment work live. And first, at the beginning of our event, I would like to say sorry because most of the devices, I mean TDR devices, are in Russian and the software is still in Russian. But in case you are going to procure these devices for your clients or for your personal usage, of course, we will make them in English and they will be supplied with English user manual. But today, for demo purposes, we're having only devices in Russian. So I'm sorry for that for today. But generally, as these devices have pretty self-explanatory indication, we will be able to tell what's happening with the cable despite the software of devices is in Russian. Okay, I would like to start with the portable device which we're having here. Let me check the batteries. So this is the TA3.3 cable fault locator. It is operated with four AAA batteries or accumulators, and it can detect cable faults up to 5 kilometers range. So if you're having a small electric cable, you can detect the faults, the damage of the cable. I mean the interface short circuit and the breakage of the cable. You can detect it with this device. But its opportunities, its functions are limited with 5 kilometers only. So it's like a smaller portable version for fast relocation of cable faults. Of course, this device works with high voltage cables, low voltage cables, and it has all the features of most commonly used electric time domain reflectometers. But still, this is a entry device in the range of TDR equipment. Also, we're having this bigger one, TDR 4.7. This is a big one. It has internal accumulators and a charger for external power supply and charger for the accumulators. It has USB port for storage of the data, and you can upload and download the information from it. It supports everything. You can uh, use various methods of location. You may have time domain reflectometer, triggered reflectometer, and wave reflectometer with optional ADG uh, 20 transmitter, which we're having on our website. You can check it out. And also, it has pretty much uh, extended control buttons and a lot of settings, a lot of opportunities to compare the signal and to analyze the signal. And also, this device is more protected, as you can see. It is IP65 protected. It has a lid which covers it safely, so you may use it on substations and in more rigid conditions than usually. And also, this device has a big, you can see that it has big color LCD display, which can help you to identify the faults better. And the main advantage of this device that it allows to measure the cables up to 256 kilometers. This is a very, very powerful device for this particular application, and it will work fine. We tested it, and it is very, very powerful, and it is the most advanced TDR that we're having in our new line of products. So I strongly recommend this device if you like to have the most multifunctional TDR equipment ever existed. This is a Russian-made device, originally made by Techno Ac, so it's very powerful, and I strongly recommend it. So, what is the time domain reflectometry? It is uh, the procedure when the device, the reflectometer, sends the pulse into the cable, and this pulse is reflected from the spot of damage. It means that you have the time, you have the speed, and that is how you can measure the distance. That is why one of the main advantages of reflectometers in general is measurement of the distance to the fault. And the main advantage is that you can connect your TDR to two phases of the cable. You can send the pulse. It takes nanoseconds to do that, and you already know where is the damage, and you know the distance to the damage. And then you can use the electromagnetic location or some other kind of location to pinpoint this damage. So generally, what we're going to do today, we will be locating today two damages with TDRs. First, we will locate and compare the interface short circuit. There are two phases of our test cable, and on some point they are connected between each other, and we will be able to see how the device indicates it. Another way, we are having two phases disconnected of the cable, and we will be able to see that there is a breakage of the cable, and that's the difference and the distance. We will be able to see it. Okay, first, let us use the smaller device so we could see that how does it work. I'm taking the device itself. It's already having charged batteries, and I'm taking the leads. That's everything you need. But if you're going to use this cable, cable fault locator on a high voltage cable, you have to be warned, and this is the official warning, that you have to use mega ohm meter before locating the damage. You have to use mega ohm meter to detect if there is a high resistance damage on the cable. Then you have to discharge the cable after you use the mega ohm meter, and only after that you can use TDR. That's very important because it can damage an operator and even kill somebody. So don't forget to do that. Don't forget to discharge the cable before connecting TDR to it. Okay, I hope this is clear because it's very important. And now we're moving to our test polygon, and I will show you today how are we going to locate the cable. Let's go. Not the cable, but the fault, sorry. And today we're having our cable reel, uh, which we're using to demonstrate the cable fault location. This is a high voltage cable on which we have imitated some damages. First, we're going just to show you how the device behaves when you connect it to the cable. Then we will see that there are some damages. And after that, we will go and see where are these damages in person. So we could see how does it look on the device and how does it look in real life, so we could understand what's happening here. Okay, so first thing I would like to do is to connect the leads of the device to the TDR. It's done like that easily, and you just rotate it. Now it works. Okay, now I'll be connecting the crocodile clamps of the device to the leads which we prepared for the demonstration here, four leads. I will put the device on the ground like this. It has a stand. Now we will be trying to locate the cable damage. So somewhere between these two leads, the cable is damaged. Покажи прибор, пожалуйста. So as you can see, we placed the device on the stand on the ground, just to be more comfortable with it. And after that, we connected the leads of our device to the rods of the cable. And now I will be sending the pulse into the cable by pressing green button, this one. Сделай вид побольше, чтобы было видно, что я нажимаю, а он пуляет. Вот, чтобы было видно экран и кнопку. I'm pressing green button like this, and we see that there is a small peak on the device's screen. It means that we're currently located the something. Okay, let's make it something. And this is the scale of surveyed area, 45 meters. It means that the zonde pulse is traveling only for 45 minutes, and we are browsing only this area. And here we have the approximate distance to the fault that we are currently having in our cable. And if we're having the peak above the axis of the device screen, it means that we're having the breakage of the cable. And if the peak will be below the axis, let me show it to you like this. Just give me a second. Like this, you can see that the peak is already below the cable, the axis of the device. It means that we're having a short circuit. So let me put the leads back as it was, and we can see that approximately at 38 meters, we're having a damage, the cable damage. I would like to go and check. Let us go and check. Now we can remember that we're having black and yellow green leads of the cable. Let's go and see. So this is the spot where we simulate the two damages, the leakage of the current to the ground and the damage of the cable. So I will tell you about this later, but this is how we indicate the spot. Somewhere here, our two cables are connected between each other inside this insulation. And you can see, скажи, пожалуйста, расстояние до катушки. So it is approximately 40 meters. We do not have the measurement instrument with us now, but you can see that it is approximately 40 meters. And the device indicated that the distance to the damage is 30 something, 38 meters, as far as I remember. Now, we will try to change the, the leads of the cable, and we will be checking another damage. So we were locating the breakage of the cable, and now we will be locating the short circuit. And we will send the pulse again. Oh, sorry, wrong. Just give me a second. Again. Yeah, like this. Now we see that our graph, our zone de pulse, is traveling below the the axis of the device screen, and it means that at the same spot that we were having, there is a short circuit between these two rods. It means that there is a short circuit, and we have to check. So, general, the routine of cable fault location with TDR looks like this. You are checking all the rods of the cable, the conductors, one by one, not one by one, sorry, but pair by pair, you two by two, and that's how you're checking if there is a interconductor short circuit, sorry, and if there is any breakage of the cable line. That's how it's done. Now I am proposing to use the bigger device just to see the difference between these two equipments. Just hold on a second. I will need some time. Okay, just give me 1 second, please. So you can see that this device is bigger than the previous one. Yeah, that can be a problem, but it has a built-in accumulator, and you don't have to worry about the batteries. You just can charge it. Again, we're connecting our cable here as we did with the previous device. And all we have to do is press F10 to start the measurement, and we switch the device to measurement mode. And you can see, I hope you can see, I can close the lid a little bit so it look better like this, that now we're having a colorful screen, and we're having multiple indications here, which can be used for separate channels. You can check, you can store multiple measurements in the device's memory, and also you can see me. Hello. Yeah. So this screen is used. It was designed to be used at the outdoors, and unfortunately, it is poorly seen on your screens. But generally, it behaves very good at sunny weather. I checked it personally. Okay. Let's describe the situation here. We didn't disconnect the leads from the cable. They are there. They're connected as they were with the smaller device because it's the same cable. And now we press F7 just to start the measurement. And now we see the same picture here, but we can see that the distance between the cable and the spot is smaller. Let me check. Just hold on a second, please. Oh, yeah. Hold on. Yeah, that is why. Like this. Now we can see that the distance between the spot of installation of this device and the damage is almost the same. You remember that the previous device showed us 38 something, and it means that they measure approximately the same, but this device is more precise, it's more accurate. Also, we can do another thing. We can stop the measurement by pressing F7 button. We can save this measurement to device memory for further reports or any other data transfer. It is stored in JPEG format, in PNG format, in text format. It can be used in any way. Also, you have date and time of your measurement. You're having the distance to the damage. You can tell what's the damage is. And now we will switch the leads of the cable. We will be switching them like this. Oh, it's not that convenient, but I, I can handle it like this. And we will be pressing F7 again just to start the measurement. And now we can see that we're having another damage on the same distance, but on other leads of the cable. So it's easy as that. That is how TDR works. Of course, there are some other functions which allow you to store this data to analyze it somehow, but generally it works like this. So you measure, you identify the kind of damage, you measure the distance to it, and then all you need to do is just locate it somehow and see what's wrong with the cable on this particular distance. Okay, I'm turning this device off, and we're going back to our table because we're stepping back to the electromagnetic cable fault location. Let me put this device aside for a moment, and I think that if you have some questions about TDR equipment, that's the best time to ask them, because I'm going to drink some tea before we're moving on. So if you have some questions with TDR, that's fine. You can ask and I will reply as soon as I finish my tea. Okay, I see that there are no questions yet. I hope we will have some by the end of this event. Meanwhile, meanwhile, yes, I seen the question. I will try to reply to it after at the end of. Okay, I promised I will do. Okay, up to how much diameter cable can check with TDR? See, there is no diameter limitation because you can see that the crocodiles of the TDR are pretty small, and yeah, there is a limitation. But you can remove the crocodiles and just apply these sensors to the cable, or you can install bigger crocodiles. That's no big deal. So there is no diameter limitation. Anything that can conduct electric current and where you can connect these leads is fine. Also, there is an option. There is an option that can be used with this device where you have bigger clamps. So that's okay. What is the maximum output energy in joules, I guess? See, this device doesn't output any energy in joules. It's the pre-location device, and this is the same. If you need some output in joules, we have 200 joules transmitter, which can be used with this device, and I hope that we will be able to show it to you in some time. But for now, it doesn't have any output on joules. It's just an inspection device which measures the time of pulse reflection from cable fault. In the last case, was there a short circuit between the phases? Yes, it was the short circuit between the phases. The first case was the damage of the cable, it was cut off. One of the phases was cut off. And the second case where we had the graph be above the axis of the screen, it means that we had interface between the phases, short circuit between the phases. Yes. Can it be used to to check multi-core telephone cables? Yes, it can be used to check multi-core telephone cables. You just check two cores at once. So if you're using it, or one core, single core with grounding. Yeah, you can do that. Was the damage to the ground in the first case? Yes, it was the damage to the ground, the damage of the cable. Is this need to set VOP in instrument? Yes, generally all the cables, they have certain parameters, and certain manufacturers of the cables, they have a data sheets for some cables. And this particular device, the bigger one, is having multiple VOPs and cable parameters stored in its memory on default. But for international market, we can't have this information because usually it's not provided by the manufacturer. That is why we're proposing to you to adjust VOP, velocity of propagation, in accordance with the distance, the length of the cable. So if you're having the length of the cable like I don't know 100 meters, you're just adjusting the VOP before the location of the damage. That is why unfortunately, not all the manufacturers of the cables are providing the VOPs for their cables. Some of Russian manufacturers do, but they will did no use to you. They will do no use for you in your conditions. That is why, yeah, you can change the VOP, but pay attention to the length of the cable. Measure it somehow, or you have to know. That's a very important question. Thank you, Subhir. Can this device be used for fiber optic cable? No. This is only for electric conducting how can I say, metal content, metal cables. Okay, so optic fiber time domain reflectometer, they utilize different principle. They work in different way completely. So no, for optic fiber, it's definitely no. Okay, maybe you have some more questions. Yeah. Okay, I'm taking some tea and reading your questions further on. If in the first case the damage was to the ground, then why was the peak directed upwards? Um, I think that I gave you wrong information because it was not the ground, it was between the phases. The first damage was between the phases, and the second one was a damage of the cable. So, no, the first one was between the phases, as far as I am concerned. So, maybe I gave you wrong information. Sorry for that. Okay, let us move to electromagnetic cable fault location. And for this particular application, we will need the following instruments. Uh, the first one, receiver and transmitter. You're already familiar with this equipment. I will not be paying too much attention to these devices for now. Also, we have two options for electromagnetic cable fault locations. And that is how we will be locating the leakage of the current to the ground. When the cable is damaged and the current is leaking to the ground, and that is how we will be locating it. The first one is so-called A-frame. You may be familiar with that because most of the cable and pipe locator manufacturers are having different models, but the same applications of this device. This is so-called A-frame. We call it DKI sensor, and it works only for this much, for this distance. But if you want to inspect more expanded distance, you can use DODK sensor, which should be used by two persons because its working principle is based on usage by two persons, and we will show you right now how it's done. And it does the same sorry, the same job as DKI sensor, but it helps you to work faster, to inspect more distant areas with two people and do it faster. For this particular application, I will invite Anthony, which is going to help us today, because I need another person to help me with. This is Anthony. You also may know him, and he will be using DODK sensor with me today. So first thing, we will turn on the transmitter. Mhm. And while Anthony is connecting the cable to the cable, the lead of the transmitter to the cable, okay, I'm checking that we are going to use the continuous mode, the 512 hertz frequency, and I will start the transmission. We will wait for some time so transmitter can boost a little. Okay, it's almost done. Yes, full power. Okay, and now I will be connecting the DODK sensor to the receiver. Obviously, I'm turning on the device, and I'm connecting the sensor like this. And device automatically switches to the mode of this sensor. And we can see that we're seeing the our cable on the screen. That's pretty helpful. And also we see a real-time graph here in the lower part of the screen. And that is what we're going to use to locate the damage. Now the signal from our transmitter is coming to the cable, the same cable we tested with TDR, and we will be using our bare our hands without any gloves to make uh, to evaluate the electric potential difference. That's hard to explain, easy to show. Let's go, I will show you. Because let's do it in practice. So, 32. Please. So what I'm going to do, I take the receiver in one hand and I'm taking one of the leads in another hand. And what Anthony is doing, he is taking the lead, скажи в ладони-то, что-то зажал туда. The lead of the sensor in his bare hand. It is very important that you use this device with bare hands. No gloves, no protection, just like this, because it makes its operation possible and effective. And we're going alongside the cable. We have to be sure that we're holding our sensors on the same level. I advise to use it on the waist level so you can be sure that your colleague is doing the same. And what you have to do, you have to move with the receiver and sensor and make sure that the wire of the sensor is not touching ground. That is very important. So you're just holding the sensor like this, and you're just holding the receiver, and you go alongside the cable like this. Oh, sorry. And that is what you can see. Подойди, пожалуйста, экран покажем. You can see that the signal, the graph, is showing something, but the signal is not very high, and it shows some undistinguishable measurements. But then we move further, and we're holding the sensor and receiver. We're keeping it inside, keeping the cable line in the center of the screen, and we're observing the signal like this. And we see that there are some changes which are not significant. And now you see that when we approach the cable, we're having a stable reading of the signal level. You see, and now we're passing it like this. And now the signal decreases and increases again when Anthony is passing the fault. That is how it's done. And when Anthony is passing the fault, the signal gives us a peak again and decreases significantly like this. You can see it. And now you can see that Anthony has passed the fault. Let us find the spot of the fault. You see, we're having the distance something like uh, 5 meters approximately. Yeah, 5 meters. And the spot of the damage is here. You can see it here. This is the leakage of the current to the ground. We have connected the transmitter to this yellow-green lead of the cable, and it is just leaking to the ground right here. Yeah, we just stick the lead to the ground. It's easy as that. And that's how we located. But we didn't pinpoint the damage. We just located the spot. Suppose you're having the cable which is longer than that, and that is how you can use the device uh, to see. Suppose you are having 300 meters cable, 1 kilometer cable, and you can just go all the way and test it and see what's the section which is containing the fault. And that is why you can use the ODK. That's where it is helpful. And when you have located this area where the signal is changing, you can use DKI sensor to pinpoint this damage. And now I will be showing how it's done with the device. Again, we're connecting the sensor to the device. It is detected automatically. No need to do anything. And I will be decreasing the gain for this particular application. We will keep 10 dBs. This is going to be fine. And we will go a little bit here just to see what does this device do. You just stick the probes of the device to the ground like this. Make sure that you stick it not far from the cable and that it's stuck to the ground, not to the leaves or something like that. And you can see that the signal is almost absent, but you can still see the cable. So the cable is there, but the signal is almost absent. And you go meter by meter, checking the section which you have previously located with the old decay sensor. I will go a little bit more just to save some time, but the procedure will be the following. So as soon as you start approaching the damage, the signal will be increasing. As you can see, previously we've seen something like 1 or 0, and now it's becoming 5 to 6. And now we're approaching a little bit more to our damage, like this. And we're already having 41 indication of signal level. And when we're putting the first lead of our probe here, and another one we're putting here, we're having maximum signal, 70. You see? So this is how we can tell that possibly we have located our damage. But when we put the damage right between the probes of our sensor, please show. We will be having the lowest possible signal, 4. So when we directly put the probe in the spot of damage, we had 60 something, and now we're having 5, only 5. And the sensor is positioned right above the damage, you see. Then you can go like this, and again, you're having your damage. One of the probes, one of the probes is standing near the damage, and the device is showing maximum signal. So that is how you locate the damage. And you can go all the way in case you are not sure that you have located something. And you will be locating nothing, basically, 7 or 6. And you can go, it will be 0, 1, yeah, like here, 2. But when you will be approaching the damage, the leakage of the current to the ground, the signal will increase. It will increase, then it will decrease when the damage will be between two legs of the sensor, and then it will increase again when you place one of the legs of the sensor again above the damage. That's how it's done. So basically, this is one of the best ways to locate the leakage of the current to the ground with electromagnetic equipment. So that is how it's done. That was a pretty fast demonstration. So in case you have some questions, this is the best time to ask them because basically we're done with the demonstration, and now it's time to answer your questions. So please do. I am going to put the equipment here. Yeah, I'm taking off the helmet because we're already safe. I will take my phone. How do you select the frequency of the locator? That's a very good question, but it's not connected with the topic of our today's webinar, but I will reply. The general advice for the selection of frequency is the following. Start the usage of transmitter with lowest possible frequency. For different conditions, you have to use different frequencies, and that is fine. But you can't say for sure that these particular conditions require this frequency or these conditions require another frequency. Start with lowest possible. As soon as you're getting uh, good result, just stop increasing the frequency. Usually we start with 512 hertz, and then we increase if we are not getting a satisfactory result. If usually we increase it to when we have some complicated conditions. I mean that where there are other cables or pipes nearby, when we are not sure that we're tracing the cable that we need. In these cases, yeah, we change the frequency, but generally we start with the lowest possible. Should the other end of the cable be grounded during testing? Yes, it should. It definitely should, because you're creating the electric loop and the electric circuit, call it whatever you like, but yes, you need it to be grounded from both sides. On one side, we're grounding the transmitter. Please show. This is the grounding rod of the transmitter and the crocodile clamp connected to it. And the other side of the cable where we've been locating the damage is also grounded. Yeah, if you want to locate the cable successfully and the cable damage successfully, you have to ground it from both sides. Is there any need to increase gain factor when distance is increasing? No, you have to increase gain when you are not having clear indication of the signal level. Suppose when you use DKI sensor and you go all the way the cable and the signal is zero everywhere, but you are sure that there is a damage of the cable somewhere. You increase the gain a little bit. Also, don't do too much gain in one spot. And you are going all the way again with increased gain, and then you are checking the cable again and again until you find the damage. Because yes, there are different signal levels, and there is small leakage of the current to the ground, and there is big. As you could see, we just have small metal object stuck into the ground, and the current was leaking, and it was very small, and the device could detect it very easily. Both devices could detect it. So yeah, you have to adjust the gain in case you are having bad readings of the signal. Do other high voltage testing cables, sorry, affect testing? No, for both TDR and electromagnetic, no, they're not affecting. Uh, in case you're having multiple cables in one spot laying nearby, it happens sometimes. The device will indicate you the spot of the cable damage of the cable to which you have connected the transmitter. But when you will be excavating the spot to see where is the damage and you will not be able to see it, so it happens sometimes. You can use inductive clamp to identify your cable. You can use MED sensor to identify your cable from this bunch. So you have to use some extra equipment to identify your cable. But other cables will not be affecting, I mean, in a signal propagation level, no. Can we check cable insulation damage? So basically, we did it just now when we were checking the leakage of the current to the ground. If the current is leaking from the cable to the ground, it means that the insulation is damaged. Yeah. Also, it can be done for the pipes. If the pipe is having plastic insulation, there are some pipes that have, especially in Russia. You can use the same way to check if the installation is damaged somewhere. Yeah. Hmm? Wood, snow, or wet soil mislead us when measuring. Generally, there is a chance that it can happen, but you can always make sure that you are putting the sensor strictly to the ground. Uh, in Russia, when it's winter, the soil is hard as concrete, and yeah, there may be some problems. But generally, if you're able to stick the sensor to the ground as deep as possible, because you have something like 3 centimeters here, generally it will work even if you apply it to the ground surface. It works on the asphalt, on the concrete, it's fine. But the best result is achieved when you stick it to the ground as deep as possible. So I guess if your soil is not hard and it's not that cold outside, then it's fine. You can use it, and it will not affect the measurement, the testing. Okay, waiting for more question. I'm checking. So I see that uh, there are no questions left for us today. So what am I proposing? You can use our website. You can use WhatsApp. You can use email, Facebook, YouTube, anything to reach our specialists, to reach our engineers, and we will reply to your questions in no time. Uh, I'm having another question here. Any interference from other services nearby? No, I've already replied to this question a couple of minutes ago. There will be no interference because we're connecting to particular phases of the cable, and we're testing the particular cables on a particular frequency. So any interference should be excluded. I also told you that you can use a pinpointing device like inductive clamp or cable identification accessory, which can be used. If both cables snapped, I can't imagine what you're talking about. Uh, if you mean that the cables are actually connected between each other because of the damage. I mean, if they're boiled to each other, yeah, there may be the signal may go to both cables, but if you use TDR, you will be able to check the cables and to locate the damage. So I propose to use these devices in the whole uh, set before using high voltage testing. So first you pre-locate the damage with TDR, then with inspect the cable with cable locator and electromagnetic sensor, and only after that, if nothing helps, you can use the test van with high voltage transmitter. And it will help you if the both cables snap. That's the answer to your question, basically. Okay, I thank you for joining us today. Thank you for your participation. I thank you for your questions because this is generally for TDR, it's kind of new area for us. We're getting familiar with this equipment also, and I really hope that you got interested in our equipment. And in case you're having some questions, do not hesitate to contact me or our team anytime. We will gladly help you. Thank you again for joining us. I hope that we will see you in 2 weeks on our next webinar. Thank you very much. Bye bye. Stay safe.